Hey there, thanks for stopping by. On this segment of Let's Code, we are going to be coding a hash map in Java. Hash map is one of my favorite data structures in particular because it's very efficient and it's simple to understand and it's used pretty widely as far as development is concerned. So there's a lot of data structures that you might discover that aren't used quite as frequently as others are, and you might think, well, why am I learning this? It's not practical. But a map you're going to be using all the time, so it's very good to take the time to learn it up front and really get comfortable with it. So today we are going to be coding a hash map with an array-based implementation to store the keys and linked list to store the values. So let's go ahead and create another package here under our data structures directory, and we're going to call this HashMap. So I'm expecting that you already have some familiarity with the HashMap data structure itself. If you don't, pause the video, go look up a quick YouTube video on what a HashMap is. You'll learn about keys, you'll learn about the hash method, you'll learn about collision detection and collision strategies, but primarily just get familiar with it before you start to code it. So what we're going to do here is we're going to create our new Java class called HashMap. And the first thing we want is the capacity of the HashMap. So let's go ahead and define this as capacity. And we'll set that to 10 initially. Okay, the next thing that we need is the actual array. So let's go ahead and set that up. And this is going to hold integers. The key is going to be an int value. The idea behind the hash method is you take an object, you perform some function on it, and it returns a value. So it's a quick way to find an object based on this hash value that's returned. So we're going to store these hash values in this integer array. We're just going to call this array. We're not going to initialize it just yet. Alright, so that's what we'll have for now. Let's go ahead and create our constructor, public HashMap, and we're going to pass in the capacity, and we'll set this dot capacity equal to capacity, and we'll go ahead and instantiate our array. This is going to be an array of integers. Okay. Actually, this is going to be an array of linked lists, because in each linked list we're going to be chaining the values that get hashed into those buckets. So what we want to do is, when I said it was an integer array, I was wrong there. We're going to do just a classic linked list, and we'll use our linked list stack implementation from previously. I think that'll be fine. Okay, and then we're going to do new with a capacity. Alright, so we'll try our linked list stack implementation. There's a video that I did previously, how to create a linked list, so you can go back and view that one if you're familiar with what this data structure offers. We might need to change it to where we can actually iterate through it appropriately, but we'll tackle that when we're looking at the find method. So now with our constructor, we have the capacity set. We've initialized our array of linked lists, and we should be good to go. Let's go ahead and also provide a no argument constructor just in case they want to use the default capacity, and we'll initialize the linked list there. Okay. So first we need to create our insert method. So what we want is hash maps. You can pretty much insert anything into, but we're going to do a hash map of strings, I think is what we'll use for this one. So we'll do public void insert string value. Okay. And what we want to do is first we want to figure out what the hash is of this particular value. So let's do int hashcode equals value dot hashcode. So if you're working in Java, Java has a built-in hashcode on every object method or every object type. So if we go into string and we check it out, we'll see it is of type object, and it does have the hash code method. So this is what this particular hash code method looks like. If you want to take a look, you can see what it does is it iterates through every character and performs a function on it. And the idea of the hash code is that it always has to return that same value every time. So if I pass in the string Corey, every time I should receive the same hash code back from that. So we're going to take that hash code and then we're going to do mod capacity. And when we do the mod capacity value, it'll ensure that the value that we get is an index in our array. So let's just print that hash code out. Hash code for value plus value is plus hash code. Okay, so let's do our main method. I just want you guys to see some hash codes for some different values. So PSVM is a shortcut in IntelliJ that you can use. It's a templated method that will allow you to just insert this quickly. Okay, so let's go ahead and create a hash map. So be our hash map. And we'll just leave the default capacity. And we want to do hashmap.insert. Let's do Corey. And then we'll do hashmap.insert dog. And then we'll do hashmap.insert mindfulBit.com. Okay, so when I run this, we should get 3 print statements, and it should show us the hash code for each one. And it should be a value between 0 and 9. 3, 2, -5. So what you also want to do is get the absolute value of that particular returned. So let's see. Let me just Google that real quick. Absolute value in Java. I think we can do ceiling method or something like that, or .abs. Okay. So we'll do capacity dot I think we'll use an integer value here. We're going to change this from int to integer. And then on the value, we'll do dot, let's see, what is that absolute? Okay. 1 second, bear with me here. I'm just checking the absolute value method. It's math. It's in the math library. Okay, that's great. So math.abs. So notice, as we're coding, I didn't really remember how to get the absolute value in Java. Quickly Googled it and realized, you import the math library and call the absolute value method from there. So now when we run main, we should get a value between 0 and 9. And none of them should be negative. We should get 3, 2, and 5 again. Because as I said, the hash code should always be the same every time you hash certain values. So that's wonderful. So we got our 3 hashes. That means that Corey is going to be put in array index 3. Dog is going to be put in array index 2. mindfulBit.com is going to be put into array index 5. So the problem happens when, what happens if I take another hash and it hashes to the same index. Well, that's when the linked list comes into play. So let's say something else hashed to value 3, and it will because we only have 10 spots. The fact that we're doing this modulo capacity means we're almost guaranteed that we're going to hit one of our values again. So at that point, we need to add it to the linked list. Each index in the array should hold a linked list and not a value. So what I'm going to do here is I'm going to say if array at hashcode equals null, I want to set array at hashcode equal to new linked list stack, and then I want to also add the value to that stack. So we'll say now linked list stack linked list equals array at hashcode. So this is just me retrieving the linked list from the index hashcode of the array object. And now we're going to say linked list dot push, and as you can see, our linked list is only taking integers, so that's a problem. So what we're going to do is we're just going to use the basic Java implementation of a linked list. We won't use our own version that we created. So now I'm going to use the linked list that comes with the Java util class. Okay. And linked list. So now I should be able to do linked list dot add, and I'm going to add value. So now what we have is if we do end up hashing to the same bucket, we've got a chained linked list in that particular bucket. So imagine, okay, here's a good example. Imagine if I were to set this capacity to 1. Let's see what it would look like. Zero, zero, zero is the hash code, and that means our array has one object and with one linked list in it, and now we're just adding different values to that linked list. So instead of getting a constant lookup time, because ideally when I say, hey, find this value, it should hash to a single entry in our array and give me the value back. But if we have collisions where multiple objects are hashing to that same bucket, well, then now we've got to iterate through every one of those to find the object. In this particular instance, the find method is no better than the find of the linked list itself, because we only have a single linked list here. Everything is getting put into the same bucket. So keep that in mind when you're thinking about the different capacities, the different sizes that are at play here, and a lot of this happens under the hood. You could just use java.util.hashmap, but since we're trying to learn it, we're writing this one from scratch. So we've got our insert method. If I were to do our find method, public boolean find, actually, yeah, we want to find a string value to see if we have it. What we do here is we're going to take that value once again and get the hash code. And if array at hash code equals null, well, we're going to return false. Else, let's get the linked list associated with this entry, which is array at hash code. And now we need to iterate through the linked list. Let's see. For string s in linked list dot get. Actually, let's do a for loop here. for integer I equals 0, I less than linked list dot size, I plus plus, if linked list dot get at I equals, and we're dealing with strings here, so I like to do string utils dot equals string utils, make sure it's the right string utils class. Actually, I don't have that package imported here, the string utils that I want from common.lang, I believe. So let's do if linked list dot get I equals value, return true. Okay, and then we'll return false there. So let's check HashMap dot find Corey, and let's print that out. And let's run it. We should see 0, 0, 0 again because everything's hashing to the same bucket. And we should get true. Now if I put a lowercase c, let's see what we get there. We should see 0, 0, 0 and then false. Okay, perfect. So now you can see, let's go ahead and increase our capacity here back to, let's set a capacity of 20. And we should get values between 0 and 20, 0 and 19. Since we're dealing with index arrays starting at 0. 3, 12, and 15, great. So it should still work the same way, but now we've got our array with more entries, so we can have more buckets, which means now we have a linked list at 3 that has one object, we have a linked list at 12 that has one object, and we have a linked list at 15 that has one object. So looking up Corey now takes constant time because we don't have to iterate through all of the potential collisions in the linked list that is setting at the array index of the hash code. So now that we have set it to lowercase, we should get a false. 3, 12, 15. Now let's capitalize it. True. So that's the main idea. So, remove function would do the same thing. You would get the hash code. You would take the remainder of the capacity so that you would fit inside of the array. Make sure you get to the right bucket, and then you would just take it out of the bucket. So that's a very high-level description of what a hash map is with a simple array implementation with a backing linked list for bucket representation. I hope you guys enjoyed the video. Thank you so much for watching, as always. And do check out mindfulBit.com. It's got all of my content there. Also offer coaching services to really help get you to the next level. I would love to talk to you about your career, where you want to go with it, and the areas that you might struggle with. So a lot of times we don't even realize there are areas that we can improve on. So I'd love to offer you that insight and once again help get you to the next level. So thanks again, and I will talk to you on the next video. Bye-bye.